Welcome back to round 3. Thank you for joining us again from Cape Canaveral Space Force Station in Florida, where we are ready to launch Terran 1, the world's first 3D printed rocket. Today's flight is named Good Luck, Have Fun, or GLHF for short, and this is Relativity's first launch. We'll be bringing you live coverage from Launch Complex 16, which is our launch pad at Cape Canaveral, as we prepare for historic liftoff. I am Rachelle Aniceto, the Chief of Staff for the Vehicle Architecture and Technology team at Relativity Space. I support our Chief Architect, Kevin Wu, in the design, development, and product management of our medium to heavy lift reusable launch vehicle, Terran R.
And I'm Arwa Tazani-Kelly, Technical Program Manager for Test and Launch at Relativity Space. I'm responsible for supporting the teams that design, build, and operate our test and launch sites across the country for both our Terran 1 and Terran R vehicles, including operations on the stages, engines, and propulsion components. And you just heard our launch director complete the go, no-go polling with our mission control team. As you heard, all systems are currently healthy, so as of now, we're able to proceed with our scheduled launch time in just about 13 minutes. You might also be able to see in this view 3 different levels under the rocket. So the largest and lowest level is the pad deck, and directly above it is the launch table. So this is where the launch mount pins to the pad and creates that flame duct. The launch mount on top of it is one component of the transporter erector. So it transfers loads into the pad deck during hot fire tests and engine ramp up at launch. It also contains the release system or hold downs and the quick disconnect or QD carriages that provide propellant and other commodities to the vehicle when it's on the ground. We did just get an update that, according to our latest weather balloon data, upper level winds are currently go. So the T-clock is going to continue to roll.
Countdown sequence has started.
There you go. We are just 10 minutes away from this historic launch. Safety manager. At T-minus 6 seconds, we're going to see that blue fire and have ignition of those 9 beautiful 3D printed Aeon 1 engines. And then at T0, we will have liftoff and Terran 1 will fly. Shortly after, at T+2 seconds, the strong back will throw back to assist in removing the umbilicals and clear the path for the vehicle to fly. And then at T+12 seconds, we'll begin our pitch over program. So we'll go downrange in an easterly direction over the Atlantic Ocean. And then at T+80 seconds is that very important milestone of max Q, where the structural loads on the vehicle are the highest.
At approximately T+160 seconds, we'll get to main engine cutoff, or MECO, where the stage 1 engines will shut off. This is followed shortly by stage separation, and the Aeon Vacuum engine will ignite on the second stage. Second stage will burn for a little under 5 minutes, then at approximately 463 seconds, we'll get to second engine cutoff, or SECO. We'll go ahead and tune back in to mission control.
Stage 2 is on internal power. EE cradle disengaged.
All right, now those cradle arms are going to slowly release stage 2 so the strong back can retract. You can see the arms opening up there.
Stage 1 TVC checkouts running.
And now you'll be able to see the stage 1 engines gimbaling or tilting, as you see, while we're completing those final thrust vector control health checks.
Stage 1 is on internal power.
The strong back will be retracting shortly here.
Strong back is retracting.
There you go. We're retracting that black truss structure to prepare for
Stage 2 TVC checkouts.
for umbilical separation now that both stages are on internal power, and now we're doing those final thrust vector control health checks on the upper stage.
Out. Flight computer configured for launch.
Under 1 minute.
LD, are you go for launch? LD, go for launch.
There's that final go for launch. We are just over 30 seconds away until the maiden launch of this vehicle. Good luck, Terran 1, and have fun. Here we go.
Ten, 9, 8, 7, 6, 5, 4, 1. Lift off. Terran 1 has cleared the tower. Control maneuver starting. Launch pad safing.
Look at that blue fire! The vehicle is now headed downrange in an easterly direction over the Atlantic Ocean. Our next ascent milestone is max Q, around 80 seconds.
Terran 1 is supersonic. Get telemetry switch over at the ground station. Max Q.
We are on our way to making a new history. Terran came ready to play today. You just heard that call out indicating Terran 1 just made it through. Max Q. We just completed a major step in proving to the world that 3D printed rockets are structurally viable. Up next, we'll be looking for a call out that stage 1 performance is nominal. As you can see, we were waiting for MECO and upper stage ignition. This means that we had a main engine cutoff for stage 1, and directly following that, we had second stage ignition, which you can see the Aeon vacuum engine in that beautiful view in the night sky. Reminder, there is no fairing for this maiden launch as we don't have a customer payload, but we do instead have a memento of the first ever circular test print. We are currently standing by for an update on what's happening with the stage 2 engine.
Announcement on countdown. This is the LD. There has been a T plus anomaly with stage 2. LC, please begin anomaly procedure section 25. Copy.
As you heard from our launch director, we did have an anomaly with stage 2 during flight. But maiden launches are always exciting, and today's flight was no exception. Although we didn't reach orbit, we significantly exceeded our key objectives for this first launch, and that objective was to gather data at max Q, one of the most demanding phases of flight, and achieve stage separation. Today's flight data will be invaluable to our team as we look to further improve our rockets, including Terran R.
Our team will now carefully analyze this data to determine what led to this outcome. So stay tuned to @Relativity Space on Twitter and relativityspace.com for additional updates in the days and weeks ahead.
I want to thank the entire Relativity team for all of their hard work in getting us to this point. No one's ever attempted to launch a 3D printed rocket into orbit, and while we didn't make it all the way today, we gathered enough data to show that flying 3D printed rockets is possible.
As Arwo mentioned, we will apply the lessons learned today in our future vehicle, Terran R. What we are doing has never been done before, but it is undoubtedly a worthwhile endeavor that will transform the aerospace industry forever. And with that, we will conclude our coverage for tonight. I am Rachelle Aniceto. It has been an honor.
And I'm Arwa Tizani Kelly. Thank you, and see you next time.